So welcome this morning, folks, to what I'm calling Digital Library Systems, the basics. The idea behind this is that we have broken up what used to be Digital Library 101, and I saw that maybe half of you guys have taken something akin to that. For the other half, welcome. Digital Library 101 used to be, with the previous architect, this sort of wide-ranging set of explanations and descriptions of our current digital repository, the Stanford Digital Repository, like the whole system. One of the things that myself and a couple other people in DLSS realized was that that's just a really, really broad topic to have in a 1-hour meeting, and I'm not good at freestyle, so we tried to break it apart into more tailored sessions, which is what this console page is for. So you can see the sessions that have been sort of proposed and what we're thinking about here. So if you don't know me, I'm Christina Harlow. I'm the acting SDR architect, which can mean whatever you like it to mean, but it also means that I have more of a systems view. So what I'm going to do today is sort of a high-level walkthrough of our current system and the changes we have on queue for the short-term future. I'm going to try to not make this too technically oriented. I'm not going to try to dive into details because that just requires more time, and this is supposed to be sort of like an overview of the 2 systems courses that we have. But it's also because we had a couple new hires actually who needed to just be caught up. And so we opened it, and I'm glad to see so many people here interested. So that's what we're walking through today. If you have any requests for other sessions or other information or proposals for these Digital Academy sessions, you can contact me. You can leave. We have a Slack channel. Feel free to jump on there and give your feedback or propose another session or whatever it may be. And we're hoping in early 2019, Hannah from PSM will be doing a more general introduction that's focused on like what you do as an end user, not the kind of system view that we're going to go. Although you'll see a little bit of that today, but it'd be much more focused on that. So that's what we're trying to do today. That's Digital Academy. Hopefully everyone has access to the notes doc. It was shared in the calendar invite that I sent to you guys. Okay, cool. Feel free to use it if you want. There's a notes section if you want to. Feel free to share it out if you want to just remember the resources later. I try to use this as sort of like an aggregation page for what a bunch of resources and links and stuff, because our documentation, like our system, is spread out among many, many, many places and is of varying currency. So for today, sort of went over the session. I did see what your interests were. Thank you for doing a little mini registration. I know it's a little annoying, but it helps me understand where we're coming from. Originally, this was like evenly divided between every system. Like, well, dang, I can't. I don't know what I'm going to focus on. Luckily, it seems like a couple things have come to the fore. There's an interest in door services, which we'll go into if you're not sure what that is. So we will talk about that a fair amount. Workflows and robots, which if you don't know what that is, this will be actually really helpful for a lot of people to understand why when you want to just do one minor update to a data model, it ends up affecting some core middleware and infrastructure. So we will be going through that a little bit. And then data models came in third. So we'll talk a little bit about that. The other things we will go through, but it just won't be as in much detail, and we can have other sessions to go through that. And I've got your questions. If and when there's time at the end, I'll go through the ones that we don't answer explicitly through this walkthrough. And we can make sure that they're answered offline if need be. So thank you for that. I was trying to look for trends in the questions, and there weren't, and that's okay. That's all right for our system. Okay. Oh yeah, so also I'll explain more at the end what taco truck means, but if you want to see a write-up of basically what I'm about to go through, there is a write-up here, and you can read through it. Again, this is more systems-oriented instead of user-oriented, but if you're curious, All the definitions are there. All of the stats I'm going to give you are here. All of the diagrams I'm not going to show you today because I don't want you to hate me are here. It is all here. Okay. And there is also a glossary there. This glossary is not, I mean, it overlaps somewhat. I know that there's a glossary on the DLSS console page that has more terms. Again, this is systems focused. So if you want to know, if we keep saying SDR1, which is a thing that still exists, if you want to know what that is, you can go here and see. Homegrown Java still has some stuff in it. That was the definition I got before our previous architect retired. So you can see that kind of information there. And we actually required this before getting into SDR3 design so that we all understood, even within DLSS, that we were talking about the same thing. That was, you know, it was a vocabulary problem even internally. So I think that's scope. We've started recording. We've seen people's interest, and you have places to go if you have questions, again, for the systems view. I know that PSM is trying to update some of the documentation that's in their bailiwick. That will be more user-focused and more like how do you get something through an Argo or those sorts of questions. While I'm going through this, if you do have a question, you can feel free to ask it in the chat or just jump in. If I feel like we can get to it later, I might postpone it or bookmark it and come back, but do feel free to ask if anything's unclear. Okay, so topology. What we currently have now is in the Stanford Digital Repository. Before I even jump into this, when I say the Stanford Digital Repository, we're talking about all of the possible ingest applications. This is Hydrus, which is sdr.stanford.edu. This is pre-assembly, which is what you ask Ben Albritton to like queue up stuff, or we're starting to train more people to be able to run those pre-assembly scripts. It is ETDs, it is the web archiving ingest workflows. All of that stuff through to our Fedora metadata store, which we'll talk more about. The Argo app that you interact with is on top of that management sphere, through to preservation and what gets released to publication or the access side that then gets pulled into an exhibits collection or gets indexed into SearchWorks. That is the whole system we're talking about, including that long-term preservation that we wrote. And just to give you an idea of the scope, we're talking about something like 106 to 110 code bases, and we're talking about hundreds of machines that this runs on. So there's about 1.6 million resources in it. That's not files, that's resources. And we have about half a petabyte of digital assets in preservation. We've got about 400 terabytes, I think, in the access sphere. And we've got like a half a petabyte backlog for various reasons that we'll go into. So I really do mean the whole thing. I'm not just talking about preservation. I'm not just talking about the self-deposit app, the whole system. So when this was originally designed, which was 10 years ago now, Lynn McRae, who was the previous architect, he really thought about it in this three bubbles idea. And if you hear three bubbles or the spheres in DLSS, this is what we're referring to. The concept was to have it separated so that management, access, and preservation all had their own data models, all had their own functions, and would just interact through some very well-defined protocols or workflows. So this is, if you know anything about Samvera or Hydra applications, this is where we diverge a bit from the core community code base there. It's not one application that keeps the files in the same place that we manage them and access them for AAAF or for indexing the SearchWorks, whatever. They are distinct, separate spheres with code bases that are meant to implement the idea that there are separations. And this separation in part is like you don't want, if someone breaks into our access sphere, they can't get to our management stuff. If someone gets into our management, they can't go wreck our preservation. There's a lot of security as well as just sort of conceptual reasons for this separation. But the three spheres, like this is what I'm going through on this wiki page was the original documentation that, or part of it at least, that Lynn would go through when he was describing this. I'm going to just scroll down to this part before I jump off to some other stuff. The idea then is that a lot of the code bases would fall into these spheres and the separations would be workflows. So management is where you're going to find all of our ingest applications. It's where you're going to find door, which we'll talk about. Sort of the heart of all of our management actions. Argo is there. Any of the blue buttons in Argo, not any of them, but like 90% of the blue buttons in Argo map to door actions. So door is sort of our junk drawer gem of functionalities and data model understandings. And in the management sphere, we have Fedora 3. Fedora 3 is a digital repository database that has a particular file system and data layout, which we'll talk more about when we get to data. It is where we keep all of our metadata. We do not keep any digital assets there. It's only our metadata. Across versions, which are user-defined. Yeah, it's all there. In the management sphere, when you actually put digital content into it, the assets themselves, it goes into a space called workspace. It's just an NFS mount if you care about that. And what happens is the metadata will get updated as we will wrap and make a preservation object, which we call a MOAB, and send it to long-term preservation. Once preservation sends a check back to management to be like, check, got it, it's good, it's preserved. It will then also, if it's meant to be published, it will be a subset of some of the metadata and some certain of the files generated. And we'll talk about, I know one of the questions about what files get generated when. We'll talk about that. But those get released to two NFS mounts in Access. It's Perl and Stacks. It's actually more complicated than that, but for the sake of this, we basically dump them on a file system over there, and that's all that Access has access to. And so you have, once it is in preservation as a MOAB, and once it is in the Access sphere as a subset of that XML and the delivery files that we've indicated we want, it will actually, the file itself gets removed from Workspace over here, and we just keep the metadata. This is purely a cost-saving consideration because you can see where we have 3 different replications of a ton of content. It's something that I've gone back and forth on because it would be really nice to keep these files here because this is why if you've ever had to do a retrieval or a request to get an item from preservation via Argo, because let's say it's something that's dark, it's not been published, that's why we have to go to preservation and grab the file and bring it back. So we're going to dig into this a little bit more, but that's sort of the mental separation. This is sort of the model that was in our heads when we were, or when Lynn was doing this, design for the last 10 years. What I did when I first got here, I could not get my head around how that actually mapped to anything. So we started this thing called a current state review. This needs to be updated, but it's fine to show a little bit more of what we'll walk through in a second. And here we go. So in theory, the spheres makes a lot of sense, and we've actually had other institutions in our communities start to recognize like how the intelligence of separating like access from preservation from management. In practice, this was developed by tons of engineers over time, people working by themselves, people working in small teams, people working in big teams, folks working on stuff by themselves and then leaving. There was a lot of work done, which has led to uncertain implementations in places and really good implementations in others. So one of the things we did when I first got here, about approaching 2 years now, was to go through all of the code bases I could find, and just warning, not all of them are in GitHub. They're not all under version control, just if you're thinking that way. And map them to the functions that they perform and then see if those map to the spheres. But it was more of a bottom up instead of a top down. So this is where we got through like all of our ingest applications. Pre-assembly has now been pretty heavily rewritten, but the code bases still fall apart the same. Web archiving, ETDs, Hydrus. This goes into this thing called door services. As I was saying before, door services is a gem. It's just a library, just a set of code base that defines all of the expected functions on a resource in the management sphere, as well as the expected data shape. So this sort of makes sense because you would want to keep that all in one place. It means, though, that when you want to, like I want to add something so Gooby can be processed, you have to update it there and then make sure where it gets picked up downstream has been adequately updated as well. It's a separation of concerns that is identified for trying to clean up so that we don't have to do so much infrastructure work every time we want to update a data model or a function. But I'm getting ahead of myself. Door services is really where all of that logic lives. Surrey is our identifier mentor. There's nothing really more interesting to talk about here for the time being. Fedora 3 is where our metadata is. Robots and workflows. So these are our robot suites. These have changed. I need to update them a little bit, but this is still mostly accurate, at least in how many there are. So when something gets into Fedora, I'm in Hydrus and I submit something. It goes through Door services to understand what we need to do to it. And then we have an asynchronous processing system that is also how we derive the state of a resource. And you'll see the states in a second. That gets run by these things called workflows and robots. Workflows define what steps in what order need to occur, and robots are the actual bits of code on machines that are just waiting for something to be ready, and then we'll process it. And a lot of the robots code then goes back and references Door services. So you can see that there's sort of a combination there. Robots, particular workflows and robots are how things get into the Perl mount. That's where our metadata is, or the subset of the metadata that we publish for access. So if you've ever gone to the Perl URLs with a particular identifier, it's pulling off of that Perl NFS mount into an application. Stacks, what files get generated and which ones are served up for delivery. That's what gets passed to Stacks. That is a particular robot's workflow. Wowza, I'm not going to go into. There's also Stacks we talked about. On the flip side, robots also manages how things get packaged and sent to preservation. So you see that's that interaction as well. And then for indexing, access, and discovery, all of that should really be happening from Perl and Stacks on. They should not care about anything before that. So when something new shows up there, a new traject indexing pipeline will kick off, which is just a code base, new indexing pipeline. Once the files are in Stacks, you can have ways to serve them up through embed. Argo is something I'm noticeably skipping around here. Argo sits on top of Door, the gem, and Fedora, and that workspace, that place where stuff is stored in management temporarily, and allows administrator functions on top of it, basically. And the Argo index, which is the thing that allows search in Argo to find whatever kind of resource you want. Like I want to find web archiving seeds accessioned by Ben Albritton in the last 2 months with this title. All of the facets and stuff. That's made through the Argo index, which is basically our Fedora God index, which is not a technical term. I totally made it up. It's a God index because we have no other better way to search Fedora. So it's massive, and that's why it's a little bit slow. And we're trying to figure out ways to optimize it. But it's hard because it does so much. There's no like set of, you have to optimize for one set of queries, you mess up another. So that's a high level overview. We're going to go into more detail of this. I don't mean to just sort of blow over it, but I wanted to give you an idea of like, this is the context that we're in when we're going through this system. And this is probably terms you've already heard. That's where they start to fit in overall. You can see originally there was supposed to be 2 more spheres added, infrastructure and personalization. I can talk with you over beers about what that was supposed to be. Okay. So like I said, within the 3 spheres, they each have their own particular data model or data object, probably a better term. Within the management sphere, we're looking at the Door Fedora object. We really, really heavily reused Fedora 3 and its particular structure to design our resources and how the metadata relates to files, how the files relate to each other. We'll see more about that in a second. Preservation uses this thing called a MOAB. It's basically a file layout specification that expects how how you lay out the door, Fedora object metadata, and the actual files in a file system with a manifest at the top to declare what it is, and different directories for different versions. Bag it up and send it to preservation. That's basically our preservation object. And Perl is the stuff, so the stuff we released to access. The Perl metadata, I'm not sure how many people realize this, it's only a subset. It's actually a relatively small subset of the metadata that's in Fedora. It is actively filtered for reasons for various reasons. We can go into that. But it's a subset of the XML, and the stacks are only the files that are marked for delivery. Okay, so if we want to see some Fedora stuff, we have the classes. I'm going to just go to this console page. I'm going to warn you, the stuff in Chimera, if you ever look at this console group, a fair amount of it is actually out of date. But it's still, we keep it there mainly for legacy docs. It does mostly still apply. It's just some of the details have not been updated. And I guess I should do it, but I'm trying to work on other documentation we'll talk about at the end. You can see here's loosely the data model we're talking about within Fedora. Collections and sets. Admin policies are basically these objects that we also store in Fedora that hold defaults for governance purposes. You guys maybe, we also call them APOs. When someone is asking Ben to load a bunch of stuff, for example, he'll ask what APO should apply. If it's one that already exists, or what do we need to create a new one. The APO has defaults here's the agreement that is relevant for this. It has defaults for things like visibility. Should it be put in, should the metadata be discoverable, should the file be discoverable, and the access sphere, those sorts of questions. Sets item, we have items, and then the part item, if you're looking at a particular content type, it can make a little bit of sense, but it's something that we've struggled with overall across all content types, because we have such a wide variety of what a whole part relationship could be. This is one of the biggest things I'm excited to change with moving forward, but for right now, you basically have a virtual part that is another Fedora object, and there's a special relationship in Fedora that says, hey, this is contained by this thing. And you know to just jump to this other file. But it's a virtual part so that they both can be discoverable as their own independent resources. A good example of that is atlases and maps. We do have ETDs have a sort of a part relationship as well as specific to ETDs. And then you have cases like web archiving where that's a many-to-many relationship, which is really interesting. So this is the overall types that we're talking about. Again, very, very heavily driven by Fedora. We'll talk about workflows in a second. In Fedora, each of these types can have a resource that will have various data streams on it. And I'm going to show you an example of that, if I can remember where I put it. There we go. So this is looking at Fedora directly. You can see it's in test. If you're on the VPN, you can get access to this, I believe. So you see in Fedora, this is just an object for a door item. And it's vertical distribution of pelagic cephalopods. Oops, sorry, okay, something scientific. And within that, we have what Fedora calls data streams. And data streams are particular sets of XML. Sometimes it's not, but for the most part, we can consider XML that describe a particular set of metadata for the resource. So the rels extensions, the relationships extensions, is RDF XML that just relates it to other resources within Fedora. Does that containment we were looking at with the data model before. Then descriptive metadata, identity metadata, and workflows. Descriptive metadata is what you think it would be. It's descriptive metadata. It's mods. Identity is, you can just see we throw in, well, probably not because it's hella small. Identifiers, who created it, what's the label across all systems. This does not override what the title is in mods. It's just so that we have something to show up across all of it. Any tags, administrative tags, I know that people use that in Argo to say, like, I want to track this for a particular reason. That is where it gets put. A relationship to a cat key. So this is how we negotiate if something's described in the ILS and something is described in SDR. We have a workflow that can see that there's a cat key there and negotiate what needs to occur. All that sort of stuff. So we have these data streams, and one thing I'll warn, you can go poke around, but we have something up to, I've counted at least 30 different data streams, because one of the things that we've not done for a variety of reasons is to do retroactive cleanup of data streams we no longer use. So you will see both workflows and workflow. Workflow was when we first loaded Google Books like 6 years ago, and it was the first pass of workflows. Workflows, this might be a good transition to that, shows what tasks this thing has gone through to lead to whatever the current state of the object is. And these tasks are related to the robots that we're going to talk about in a second. So that's an overview of the object in Fedora. Not only our actual metadata resources are in Fedora, but we do store administrative stuff. So you can see, like, this is actually a workflow. Like, so the thing that has, these are the tasks that go through, and this is the state of the object when each task is complete, are defined here as well. APOs, or the administrative objects, are defined in Fedora. We all try to keep it in one place. Let me see, I saw that there was chat. Okay, question for later. Okay, yep, Laura, I'll get to it later. So this is an overview of the resources. You can see I try to put further information about some of the more common data streams you'll see. You'll see a lot of them do become specific to a particular thing we were trying to get done. And robot, well, we have to update not just what metadata is in Fedora, but our door services gem to be able to know to expect it and parse it, and our robot suites to know when it finds it, it needs to do some particular processing on it. Really quickly, I mentioned states. So within Fedora, or within SDR in the management realm, we do apply states to a resource, and you do see this in the Argo interface. Has it been registered, which basically, does it have a placeholder object in Fedora and an identifier? Is it being accessioned, which is fully accessioning the resource and cutting a new version? Because we cut versions defined on when you guys close something and indicate that a new version has to go. And that's why we have the close open model. So we don't want to have to cut a new version and send it to preservation every time you update a title. We're going to wait for you to say, okay, now I'm done, cut a new version. It's in ingest, it's described, published, or indexed. This is if it's being released to the access side. Again, not everything does get accessed. And then these are the states for when something is complete. So, okay, accessioning is done. Okay, it's in digital preservation, and then open is, it's been open for someone to do whatever it is until they accession it again and close it and cut a new version. These are the states that are driven by workflows and robots for the most part. And you see these in Argo. So before I move on, I would mention, let me go back to the agenda. That's a really fast overview of what we have now. And I want to take that and map it to how something actually goes through our system so that you can get more of a connection between what does it mean to be registered? Oh, it means that this task ran here. But before I do that, I do want to call out that we are actively working on reorganizing what these models look like. So instead of having these XML data streams and this very Fedora 3-centric object model, for what we've called Taco or SDR3, if you've heard about it, we're looking for a JSON-based model that would be much, much, much more flexible, because it would be JSON, JSON LD, and just stored in a key value database. So we don't have the limitations of you have to have a virtualized object because it doesn't know how to do containment, blah, 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 blah. We'll talk more about that at the end if there's time, but I just wanted to highlight that if you're interested. And I know for things like web archiving or annotations or crowdsourcing or stuff like that, if you hear me ask if we can wait till we get the new data model in place, it's because JSON, this JSON specification is much, much more extensible and flexible than some of what we have now. Not to, like what we have now has worked very, very well, but this is why you might say, can we do this after we get this new system in place? And we'll talk more about that at the end. Okay. So that's an overview of that. Now let's go through the sort of a data flow. I've tried to include links here so that you can follow along with it. But from a visual standpoint, I'm just going to walk you through if something goes into Hydrus or to pre-assembly, how it goes through here to get to SearchWorks, digital preservation, and Argo. Yeah, so let's just do that. I tried to draw a better actual diagram of the data flow of everything, and it was just too complex, and it's actually really ugly. It looks like, what's the Cthulhu guy? It looks like Cthulhu because it's like door services and then like all of these, you know, tendrils or something. I'm not really sure what is. Do you say Cthulhu? Yeah. Yeah, the Lovecraft guy. Yeah. Oh, we should name something Cthulhu. Okay. Anyways. So thinking about ingest, like I said, ingest could also include a couple other points. I'm going to just start with the most common for two things. Hydrus, our self-deposit application, and pre-assembly, the sort of mediated deposit that we've rewritten recently to try to get more people able to run. When you're interacting with these, what's basically happening is it's grabbing the metadata, it's assigning an APO so that we know the agreement and the governance expectations. It's putting the file somewhere that is retrievable by where we're running door. If you see library services, just a little historical note, all of our services, all of the SDR used to be on one VM, like back in the day, like 10 years ago, or machine, sorry, one machine, and it was called library services. So that's why you see it all over the place. That's by the way. So Hydrus and pre-assembly. Hydrus is the self-deposit app. It's basically taking it and assembling this sort of metadata file or files relationship for you. And then once it's ready to go in Hydrus, it sends a request to a REST API endpoint that is door services to broker getting an identifier, making sure everything's valid, and then saving it in Fedora and Workspace to then apply a workflow on. So when it's saved in that first save in the Workspace and in Fedora, it's not entirely done yet. It's in process. It's in accessioning. And then we wait for the asynchronous framework to pick it up and do what we'll talk about next. Pre-assembly is similar, except for we have where you can have more of a batch view on things, do some more validation before you send it through, and you basically connect to door services, that API directly. Yeah, so this hands it off. It goes to door services. There are two different forms of this. I'm not going to go into this because I don't know if you guys particularly care, but there are two different forms of how you can interact with this. It gets an identifier from Surrey, which is what mints our druids. It puts it into Fedora, and this is a link to an object that we were looking at before if you're curious. It puts the files on a particular NFS mount that maps to that Workspace thing that we were talking. I'll talk about the search index in Argo in a second. And the last thing that any ingest app does says, okay, this stuff's ready to go, please kick off, usually common accessioning. So if you hear common accessioning, that's the core set of tasks that we run on everything. Yeah, that we run on everything, hence common accessioning. Once you kick that off, let me see if I can show you an example. So here's an example of a workflow. It is probably not common accessioning because I wasn't smart enough to do that. This is ETDs. It queues up all of these processes for that resource you just sent through and marks them all as not yet completed, except for the first one, which it marks as in progress. So this is how we manage these sort of, first you want to make sure it has an identifier. Second, you want to submit. Third, ETDs is weird because we have to submit back to this an external system for then someone to come through and approve it. But this is where we manage the ET specific steps. We want to approve it, make sure it's okay. Get the mark in there so that someone on the ILS side can review it. Okay, someone on the ILS side reviewed it, it's okay. Move on further and further and further. So whenever you kick off, like the things are in Fedora, the things in Workspace, start this workflow, this is what will happen. And you'll see that a lot of them will end up daisy chaining to each other. So once common accessioning ends, it might go, if the thing is supposed to be published, it might go to a publication or whatever it may be. So as it goes through that, it is a couple of things are happening. One, we create this workflows data stream that we saw on what milestones have been reached and when, and for what version, so that we can do tracking on if where the resource is in this processing. It also, we have an API that reads into like looking at how many things are waiting in a queue. This is maybe not as interesting to you guys as, let me find, I want this guy. Please work, please work. Oh, I'm gonna have to log in. Oh no, there it goes. So this is an overview of all of those robots that run whenever a task is ready to go after being queued up according to a workflow. So you can see here, these are the various workflows, here are the robots and the jobs going on. Every resource that comes from whatever ingest mechanism possible goes through this asynchronous processing system. So it's actually quite important, quite big system. And it's one of the things I'm hoping we're going to do some maintenance on this month or next month to try to make it a little bit more stable. So you can see here, this is the state, and this is the actual queue that manages it and feeds into that task view in Argo. So when you see in Argo, there's a similar view that shows where everything is, and you can restart a task if it failed. It's being read from this. Through particular workflows, it will get shelved or published. Published is where the XML gets put into Perl. Shelved is where the appropriate delivery file gets put into stacks. If you want to see how, well, let me back up because I know there was a question about this. For understanding what kind of files get generated to go to stacks or preservation or whatever it may be, you would want to look at our robots to understand, like there will be a robot suite that will determine, okay, based off of this item type, this MIME type or something like that, I'm going to create a JP2 or I'm going to create a TIFF or I'm going to do whatever I need to do. That all of that logic is in those robot suites. And then what will happen in Fedora is that you can mark at the file level whether or not you should shelve it. So we don't shelve generally preservation files. We don't put the preservation files into the public sphere. We put the delivery files. Beyond any more detail beyond that, it's walking through the actual code to see, because it's logic that's had to expand for a lot of new types over a relatively short amount of time, so it can be a little. You were the one that asked that question, right? Okay. And I'm happy to have another session where we sit through and just really fine-tune go through that. But that's where the logic lives. Yeah. There are also separate stacks for geo and web archiving. Geo because it has a Postgres database that stores some geo metadata. Stace, I'm sure you already know about that. Web archiving has its own stuff because it has a many-to-many relationship that's a little bit different. But all of those are then what feeds into the access sphere. Perl fetcher is a thing you may or may not have heard about. It basically trolls those to say, hey, something new was added here. Update searchworks through other code bases. Update whatever it may be. Well, it's the inverse, but it does that trolling to say, here are new things. You should do this. Or something's been deleted. You should remove it downstream. The release to preservation is through a robot suite that is going to the preservation catalog. You will not be able to access this. It is locked down because we want to protect our preservation system. But we have a robot that has to run on a very particular machine with the permissions to say, hey, here's this MOAB, please preserve it. And we wait for a response before anything else happens. We don't do any other task until we know that the thing is preserved, and then we go on our way. Okay, so for Argo, as all of this is happening, I don't think this is going to show up really well, but we'll see. Let me go ahead and open this guy. So every time something happens in Fedora, it has an automatic set of queuing technologies that lets us know that, hey, something's happened, and we should update the Argo index. The community is like, it's not the most stable of notification policies, so we do have a lot of stuff that sort of runs outside of this to make sure we pick up all the changes. And yeah, it's already not like wanting to respond to me, so that's fine. Basically, it all is in theory driven from that Fedora queue. We updated a metadata, it just got updated, sent out an event, the event goes into a queue, and then we have something that does a re-indexing job for the Argo index. Okay, and then this is not particularly of interest for today, but I want to call it out because it sort of indicates the future direction that we're going in. There was recently a work cycle to rewrite the SearchWorks indexing pipeline for both the MARC stuff and the SDR stuff. The ILS stuff, I would leave to the ILS experts, but for the SDR side, we know that we want to try to make this more of a streaming real-time system, and we want to have where the mappings themselves aren't married to the code bases, because I don't know if you've noticed throughout this system, but if you want to make just a metadata change, it actually becomes a set of code bases that need to be updated instead of like some sort of metadata specification or some sort of mapping. One of the things that I've been a really big champion of is having these declarative data specs that sit outside of it that we can then have you guys run, metadata or whoever can help manage that. And instead of having to update and redeploy a code base whenever that changes, it can be picked up by the system that's just going to keep chugging along. So that's sort of work in progress, but the SearchWorks indexing pipeline that worked on this is sort of SDR3 prototype for me because it was a first pass of trying to have this more declarative looking set of configurations. And I think it's interject. So you can see, for example, this is the SDR config that we load for the new indexing pipeline. And we have where we're trying to simplify this DSL, this language, to field ID, grab record.druid. We want to make this where this can be some sort of easy JSON path or XPath or whatever it may be, and that we can have it refined enough where it's less like code and more like this spec that sort of sits outside the code that other people can update. Okay, so that's going through the systems. The last thing I'll do before I take some time to go through questions I haven't gotten through. SDR3, Cocina, Taco, all of these names that I guess is partially my fault that we have so many names, but whatever. So SDR3 started well before I was here. Well, people started talking about it well before I was here. It's where we know that there's a lot in that system that I just went through that is not the most robust. And a lot of it is because we did write it, a good majority of it 8 to 10 years ago. We're aware that we want, that folks want more self-deposit options. We're aware that it would be really good for us if we could have more distributed batch accessioning. I know the pain that we have to go through when we want to update a data model. I know that the web archiving stuff has some discovery problems. And a lot of that is trying to think holistically in how we can evolve the system to make it a little bit easier to deal with this stuff. Now that we've really sort of tested this spheres approach and how we've separated access from preservation from management, and we've spent the last year rewriting preservation so that we actually know it's preserved, getting it off of a tape library onto a different system, we know we want to rewrite this stuff, or parts of it, to like make it easier to add new features and data models and whatever it may be. SDR3 was talked about in that realm. It was originally talked about with the move to Fedora 4, which is Fedora 3, but linked datafied. We have since sort of drifted away from using Fedora 4, as has the larger community. What we're looking at now is this thing that is being called Cocina. And I'll explain, well, I'm trying to move away from the term SDR3 because it makes it sound like there's going to be a SDR2 turn off date and an SDR3 turn on date, and that's just not what's happening. It's a migration of components over time because we just have too much stuff to be like, all right, yeah, like that's not what's going to happen. So what Cocina is like the overall view, and it's only called that because I'm always hungry, so I named everything after food. And I guess we don't have to keep the food names, but I like the food names anyways. So that's why it's called that. And this overall view is thinking about how we try to replace some of the components piecemeal. We did do a prototype with developers last April. So we know overall that the technology and the development patterns we're going to follow. And as part of that, that's where we started to write the JSON models for our internal data models to make JSON LD, JSON schema, and have that separate from the code. And I've already been working with Arcadia to try to have a process for this is where the code's running, this is where we do validation or checks before you load something, or definitions within our database. Here are the data specs. She deploys something to the data specs, we can have it picked up by the code without doing any deploy on the code. So we're already trying to do that. And I think that gets to a question of someone was asking, how can I define more mods or different mods or different data profiles? The long-term hope here is that it will be easier for metadata people to own the appropriate parts of the data model through the schema specifications and through a very flexible JSON LD structure. And then when we have that passive trajectory that I was just showing, that indexing pipeline mapping, we want to expand that so that possibly even the release to Perl, instead of us really fully managing what that XML looks like, we can have it resolved to multiple formats and you can define your appropriate mapping. Now, it's not going to be open to anyone can edit whatever. There are going to be like integration tests, but it means that the specs are in one place and you don't have to wait for a development work cycle to update it. So that's kind of the approach we're hoping for, so that we can have a little bit more flexibility here. You can see the code bases here. Taco, do we not call the identifier something? Tacos, Sopa, Refritos, Torilocos. Whatever. And we're hoping in actually this April, after the next DLMA work cycle, that we will go through writing this and putting it into production for a subset of selected resources. Google Books, we want to load to do a smoke test to make sure it can scale, and possibly ETDs, something self-deposit. And this leads to a question. Someone asked, when are we going to have more self-deposit services, I believe. What we're trying to do is if I can get this level to work correctly for a self-deposit system, then we've opened up a very flexible endpoint that we could build multiple self-deposit services on. The next step after that would actually be rewriting Hydrus to work on this new middleware. And we're hoping it actually really minimizes how much work we have to do in Hydrus, because all of the business logic is now in this very clean, encapsulated Taco service. So that's sort of the path we're on now, at least on the system level. And obviously, you would want to reach out to like PSM or HANA to know more on the user side, what's going on there. But that's the general idea. One of the things that's so hard to touch about, why it's so hard to touch Hydrus, is because it is so married to calling so many different things in that lower system that it can be quite hard to know that we've moved it without breaking something or breaking something downstream. There was also a question about rewriting refritos or rewriting robots and workflows. We're already doing that work in infrastructure maintenance. There was a little, I was able to slide in some maintenance work to make it a little bit more robust. If you've ever gotten the email from Ben that says, sorry, accessioning is down, usually it's because something went wrong in workflows and robots, because everything goes through it. So if something gets gummed up, then everything gets gummed up. We're already trying to make that easier. And the rewrite here would be refritos. It's called refritos because you're refrying it. Haha, whatever. So that's already planned. Anyways, so that's where Cocina is. We do have where I can do, I've done previous sessions that are really just diving into what we're trying to do with Cocina and Taco and all of that sort of stuff. But if you hear those terms and not SDR3, that's why, because it's going to be point replacements, not a full system. And I think I started with saying like SDR1, for example, still exists as a Java code base somewhere with some stuff in it. and we switched over to SDR2 and SDR1s just sitting like a ghost. So Taco will hopefully not repeat that pattern. Okay, so we've got about 5 minutes left. I'm happy to go through the questions that I haven't answered so far, but let me stop here and see are there questions or feedback or concerns or pizza recommendations that people would like to throw out here?
So hungry.
Breakfast tacos for everyone. I also welcome any feedback on how to make this more useful for you guys, because we will be repeating this throughout 2019. The whole idea is to have this a little bit more regularly so that even, like the engineers, I think a couple of which are here, can show back up and remember why we did something the way we did or what the current state of something is. So. Okay, so let's go through these questions. When will I get usage, view, download stats? So I would imagine view download stats are going to be what we end up capturing on the access side. And because I haven't heard it doesn't mean it's not happening. I haven't heard anything actively about doing that, but I'm happy to follow that up with the JIRA ticket and bring it to DLSS Direct, of which I'm a member, and just see if we can talk about what would be needed for that and where it might fit in priorities. But I imagine it's just capturing stuff on the access side. Who's accessing Perl or stacks when? Well, I don't know what level of who we can capture on that site because we just do it by groups, but I can see. Oh, and remember, Laura, you had a couple questions, I think, over in the chat. Do you envision implementing sets or something similar in the future to accommodate the various parent-children relationships that exist between objects? One example would be an object within archival collections. Yeah, so in the new data model we have for SDR 3 or Cosina, where did I put it? I think it's here. Oh, gross. And of course, it's like a horrible file that I can't see. So let's go. All of this is in the DLSS team drive, so if you have access to that, you have access to all of this. I'm intentionally trying to put it all in the most open space possible. It should be, some of this should be just publicly available. SDR3, design, where's the data model? That's what I want. So the idea, Laura, here is that each one of these classes of resources, a collection, and we mean a very abstract collection there, object, any object contained by another object, a file set, and a file.
Oh, great. I love
Those
it.
are all separate JSON documents that point to each other.
Excellent.
So you can, this gives us much more flexibility in saying, yep, thank you.
Yeah.
If you want whatever kind of collection you want, fine.
I like it. Thank you.
Yay! It also means we have metadata at the file level. We don't try to group it in the object thing. So every file has its own metadata record, which will help simplify. Yeah.
That'll be huge, particularly with hybrid objects and objects that have files with different rights dispositions, different access dispositions, etc. So I'm very happy to see this. Thank you.
Yay! It also, I know that we are not the best at capturing technical metadata in the management sphere right now. I'm aware of that. And the idea of having each file have its own metadata is that we can capture whatever technical metadata you want us to.
Yeah, be awesome. So, really, really helpful. Thanks.
Yeah. Okay. Let's see, we've got 2 more minutes. Cataloging discovery workflows. I think we went over that a little bit. I didn't go specifically into how it relates to cataloging. Basically, the idea is if you pass a bibliographic ID in, whether upon creation of a digital resource or later update of a digital resource, we're redefining the workflows to know how to either rederive and overlay, or convert to MARC and send to the Symphony API, or any combination of that. And that's something Arcadia has been very helpful sitting with me so that we can map out the actual functions and figure out how we flag that. And then for discovery, it's just once it gets to those NFS mounts on the access side, Perl and stacks, that's that's how it gets into IIIF engines. That's how it gets to SearchWorks. That's how it gets wherever it needs to go. And that's where we actually care about the linked data aspect of it. We don't care about linked data in management. Like it's just not efficient for what we're doing. But once it gets to that end, we can publish RDF and URIs if need be. We can publish whatever format you would like in a dereferenceable form for discovery. Users really don't interact with those services. They interact with Argo and self-deposit apps. I think, Tony, you asked this one. We can talk more about what that means, but door services, so the services within door services are the things that usually map to the blue buttons in Argo. Yeah. Gave a very high-level overview of what this is. I think, Stace, you asked this. I don't remember. What I'm hoping is if we can get through this work cycle in April and clean up the data model and the middleware, then we have a great opportunity to really start to revisit Hydrus, our core self-deposit, and make it a better application, as well as what other things we might want to add that are either limited by self-deposit because the files are too big, which I'm already working on a plan to figure out how we can dump it in an S3 bucket and do retrieval in an asynchronous chunked process on our side, or because it's like a data model that is not currently something we put in support for in Hydrus. Okay, and the other questions I will answer and email out to you guys. We can meet about the derivative files because I'm happy to just show you more if you're curious. Yeah, okay. Actually, maybe I got them all. SDR3, you've heard about it now. It's Cosina. Mods application, we talked about that. That would be the JSON schema on that side and a mapping to get to the Perl. Because one of the biggest confusions we see is people see Perl mods and they assume that that's what's internal. They're actually quite different. And yeah, the easier one I can write up for someone. So thank you very much for attending this. I see I'm 1 minute over. I apologize. If you have questions or feedback, and I welcome both, you can hit me up on Slack. You can email me. You can talk to me if you actually see me. Whatever. I would really love any feedback on what would make this more helpful. Helpier? I don't know what I was about to say. I would love feedback on how to make this more helpful, or what information wasn't here, and so that we can continue to target a couple more of these sessions and make it a little bit more transparent what's going on. So, all right, let me stop recording, stop share, and no, the commands disappeared. Okay.